Welcome to this explainer. Look, if you're managing cloud infrastructure right now, there's one thing keeping you up at night, right? AI governance. The explosion of AI is, well, it's a massive opportunity, but let's be real, it's also a terrifying security nightmare. So today, we're skipping the theory. We're going to break down exactly how to build a resilient, governed AI stack, literally from the model straight to production.
Okay, let's kick things off with a number that honestly kind of blew my mind: 71%. According to Microsoft research, 71% of employees have used unapproved AI tools at work. And get this, more than half are doing it every single week. Think about that for a second. We're not talking about a tiny handful of rogue power users here. That's the vast majority of your workforce bringing their own AI right into your enterprise environment.
So that brings us to a really uncomfortable question, one you've got to ask yourself about your own estate. The issue isn't whether AI is in your network because, spoiler alert, it absolutely is. The real issue is how many integrations are running right now that you have absolutely zero visibility into. We're talking ChatGPT plugins, Copilot hanging out in developers' IDEs, or, a weekend LangChain proof of concept that somehow quietly snuck its way into a live customer journey.
To get this under control and build what we call a layered fortress architecture, we're going to hit 6 core steps. We'll look at the shadow AI problem, discovering hidden AI, classifying data at creation, enforcing access with IAM, scaling with policy as code, and finally, operationalizing the whole shebang.
So, step 1, the shadow AI problem.
Here's the deal. Traditional security basically assumes you actually know what's running in your environment. Shadow AI, it completely shatters that assumption. Picture this. A developer wires up an OpenAI API for a quick sprint, feeds it a little bit of real customer data just to test the waters, and then completely forgets to tell anyone. Fast forward 3 months, and that untested, unsecured connection is suddenly handling production traffic, and no one wants to pull the plug because, hey, it's driving business value, right? That right there is the trap.
And if you want a textbook example of how bad this can get, look at the August 2025 Singularity attack. Malicious script literally hid inside common developer packages, just silently harvesting GitHub tokens and cloud credentials. When developers leave these unapproved AI endpoints wide open to the internet with barely any authentication, they're practically rolling out the red carpet for supply chain attacks to infiltrate deep into your downstream environments. It's a massive risk.
All right, moving on to step 2, discovering hidden AI.
You can't secure what you can't see, right? And to find these hidden entry points, you really have to choose the right lens. If you want to see broad external vendor usage, like who is pinging Claude or Hugging Face from their company laptop, you need your cloud access security brokers, or CASBs. That's your go-to tool for the outside world. But if a team quietly spun up TensorFlow in a Kubernetes namespace, a CASB won't help you. You absolutely need a service mesh to catch that internal pod-to-pod traffic where self-hosted machine learning models love to hide.
So, to actually get the full picture, you need 3 pillars of discovery working together. You combine your CSBs for the external stuff, your service mesh for the internal stuff, and your API gateway logs to act as your ultimate traffic choke point. When you centralize the signals from these 3 layers into a single SIM dashboard, you're no longer flying blind. You actually have a highly accurate, real-time map of your AI usage.
Next up, step 3, classifying data at creation.
Now that we have visibility, we need to talk about data. Notice the event-driven architecture we've mapped out here. This setup ensures absolutely no data enters your storage layer without being properly classified. The exact second an object hits an S3 bucket, boom, a Lambda function triggers Amazon Comprehend. And Comprehend is perfect for this, because it can scan text snippets for PII in literal milliseconds. This real-time tagging completely eliminates that terrifying vulnerability window you get with traditional overnight batch scanning. Because let's face it, unclassified data sitting around for hours is just begging to be sucked into an AI training pipeline.
Dave Ward really hit the nail on the head here. He says, classification without enforcement is just expensive labeling. And he is spot on. You could build the most beautiful, complex tagging taxonomy in the world, but if those tags don't actually stop a model from ingesting restricted data, you've just burned a ton of time and money. Passive metadata won't stop a breach. Enforcement is literally everything.
Which brings us perfectly to step 4, enforcing access with IAM.
To turn those passive tags into a real layered fortress, we have to stack explicit IAM deny policies in this exact hierarchy. This transforms your S3 buckets from dumb storage into intelligent data guardians. Let's walk through it. Layer 1 is a hard gate.
It literally bounces any upload at the boundary if it isn't classified. Layer 2 is your failsafe. It denies reads entirely if the metadata somehow gets stripped. Now Layer 3 is where the magic happens. Even if the data is classified, it absolutely needs a specific AI-approved tag to be read by a model. And finally, Layer 4 restricts the whole thing to a designated VPC endpoint, completely blocking lateral network movement. If just one of these checks fails, the data automatically shuts out the unauthorized AI, no exceptions.
But let's be real about engineering culture for a second. If you force your developers to manually type out KMS encryption keys and massive tag strings every single time they deploy, they're going to find a workaround, for sure. The trick here is to wrap these hard gates in a totally intuitive abstraction layer. Give them a straightforward S3 client class that handles the tagging and encryption automatically behind the scenes. They'll use it without even thinking twice. You literally have to make the secure option the lazy option, because lazy wins every time.
All right, step 5, scaling with policy as code.
Standard IAM policies are cool and all, but they are way too static for modern dynamic AI deployments. This is where an engine like Open Policy Agent, or OPA, comes in. It takes your static configuration files and turns them into executable dynamic logic. Suddenly, you can programmatically say, hey, this model can only touch this specific data if the model itself passed a security scan in the last 7 days. It instantly adapts to real-time context, so you don't end up with a tangled nightmare of IAM roles. Plus, it even allows for temporary break-glass access during an incident response, creating a perfect audit trail without blowing up your security bounds.
And finally, our last structural layer, step 6, operationalizing AI governance.
Look, if you try to shove every single AI deployment into a manual review queue, your delivery is going to grind to an absolute halt. The key here is risk-based approvals. Low-risk stuff, like a weekend project using public data, gets automatic approval. Medium risk, that automatically triggers code and security scans. You have to reserve your slow, valuable human judgment strictly for the high-risk systems, the ones handling sensitive data that actually pose a genuine threat to the business.
And once it's live, you have to monitor this stuff exactly like you monitor your uptime. Treat AI governance like site reliability engineering. If a production model tries to read unclassified data, that shouldn't be a compliance audit finding 3 months later. No way! It needs to trigger an immediate PagerDuty alert right then and there. Your drift scores and access counters need to be sitting right alongside your latency spikes in Datadog or Prometheus.
So, let's wrap this up with the ultimate reality check. As you look at your own cloud infrastructure today, and you picture the developers out there trying out new AI tools at this very second, I want you to leave this explainer asking yourself one thing. Is your architecture truly a governed fortress, or is it running in the shadows? Because honestly, if you don't know the answer, you already have a shadow AI problem.